Hey guys, Miss Marian here. We're going to go ahead and look at Unit 2, Notes 3, adding and subtracting radical expressions. So again, we're going to use these perfect squares. If you don't kind of have the pattern going already, make sure you connect with me on where these numbers come from, okay? Because we're going to use them this entire unit. So you really want to make sure that you understand what your perfect squares are or how to find them, so you can write this list at the top of your page for every assignment and quiz that you have to take. So here are the steps that we're going to look at when we're trying to add or subtract radical expressions. So first things first, can you simplify the radical? Okay, so you're going to go through and just like we've been doing, you are going to simplify it looking for one square root and one number that's not a square root to break it down. Okay, so that's the first thing you always want to do. Then you're going to go ahead and you're going to combine anything. And when you're looking at these, you're looking at like combining like terms almost. You are looking for the same number to be under the square root. What happens then is you use the operation, either adding or subtracting, to combine just the outside numbers, but the number under the root is going to stay the same. So if I were to see something like this, 2x2 and 4x2, those are combining, those are like terms technically. We're going to look at them as like terms because the square root of 2 is the same in both of them. So it's still going to stay the square root of 2, and then you just put them together with the front number. So if this was adding, that would have been 6. Okay, so the radical, just like when you combine like terms, the radical stays the same. That's the mistake that most people make. Well, let's go ahead and look at this one. So first things first, I want to ask myself, can I simplify either of the radicals? So square root of 3, I know I can't simplify because the only number I could try would be 1, and that's not going to change it at all. So I'm going to go ahead and I'm going to leave these as square root of 3s. Then I'm going to go and see if there's any like terms technically I can put together. So I see that they both have the square root of 3 as their root. So what I'm going to do is it's going to stay the square root of 3, doesn't change. And then I'm just going to do the operation on the first two numbers. So this is telling me I'm going to add 5 plus 2. So I'm going to end up with 7 root 3. I don't have anything else I can combine. I can't simplify. So that's my final answer and I'm done. Let's look at number 2 here then. So I'm going to go ahead. I know that, like I said, I can't simplify root 3, but I think I can simplify root 27 because I can take the square root of 9. 9's one of my roots, and I know that times 3. Okay, so square root of 9 times square root of 3. I know the square root of 9 is going to be 3. Square root of 3 is going to stay. Now I'm just going to carry this whole thing down. So I still have the 4 square root of 3 and that minus sign. So now I'm going to look at my roots. I have a square root of 3 and a square root of 3, so I know it's going to stay the square root of 3. And I'm going to do the operation with the numbers in the front. So it has 4 minus 3 this time is going to give me 1. So you could see it this way, or you could write it without the 1 because that's just imaginary as the square root of 3. Either one of those would be correct. All right, on to number 3 here. I'm going to look, can I simplify any of the radicals? I have the square root of 2, which I can't simplify. I have the square root of 5, which I can't simplify. And then I have another square root of 2, which I can't simplify. So what I'm going to do is I'm just going to look for like terms almost. So I have the square root of 2 and the square root of 2. So I know I'm going to have a square root of 2. And I need to do the operation with the numbers in the front. So I have 2 minus 6. So if I do 2 minus 6, I get negative 4. And then I haven't touched this yet. I still have that plus square root of 5, but I don't have any other root 5s. So I'm just going to tag it on to the end, plus the square root of 5. Those two are not like terms, and I can't simplify either of them either more, so that is my answer, and I'm done. All right, let's look at number 4 here. Number 4 says the square root of 6 plus 2 square root of 3 plus square root of 12. So we're going to simplify anything we can. Well, square root of 6 I cannot simplify. Square root of 3 I cannot simplify. I know that square root of 12 I can simplify, though. So let's go ahead and do that. I'm going to break that into the square root of 4, which is in my perfect squares list, right? And the square root of 3. So 4 times 3. I know that square root of 4 is going to give me 2. And root 3 I'm not going to be able to touch, so I'm going to leave that as root 3. So I'm going to carry everything else down. So I have the square root of 6 plus 2 square root of 3 plus what I just simplified. So I'm going to put together my root 3's because those are the same. So I'm going to have a root 3, and I have 2 plus 2, so I'm going to have 4 That took care of those two things. So I still have the square root of 6 that I cannot do anything with. So I'm just going to carry that down. Those two things are simplified and they cannot be put together. So that's my final answer. So far we've been super lucky. We've only had to simplify one of the radicals each time. But I know that each one of these radicals I can go ahead and simplify. So I'm going to break them in. 12, I know I can do the square root of 4 times the square root of 3. 27, I know I can do the square root of 9 times the square root of 3. And 48, I know that I can do the square root of 16 times the square root of 3. So square root of 4 is 2. Root 3 I cannot do. I'm going to carry my sign down all the way from the top up here. So I have minus. Square root of 9 is 3. Square root of 3. Carry my sign down, which is a plus. Square root of 16 is 4 root 3. And now I must simplify it, so I'm going to try to put things together if I can. Well, all three of these have a root 3. So we're going to put them all three together. So I know I'm going to have a root 3 in my answer. So I have 2 minus 3 plus 4. That ends up giving me a 3 root 3. That's my final answer because it's as simplified as it can go. All right, last example here. So we are going to try to break everything up. Well, I know that I can break each of these up again. So square root of 8, I can do square root of 4, square root of 2. 32, I can do square root of 16, square root of 2. 81 was in my list of perfect squares, right? 1, 4, 9, 16, keep going all the way up, and I have 81. So right away, I know that 81 is going to be 9, okay? Because the square root of 81 is 9. So let's break this up. Square root of 4 is 2, and then I leave the square root of 2. Bring your sign down, plus. Square root of 16 is 4, square root of 2. Bring your sign down, minus. So now we're going to combine like terms. I have square root of 2, square root of 2. I'm going to do the numbers in front. So I have 2 plus 4. So I have that square root of 2. 2 plus 4 is going to give me 6. That minus 9 I can't combine in there at all. So I'm just going to carry it straight down. And that's my final answer, and I'm done. All right, so if you need help, come talk to me. If you're not understanding where things are coming from, come talk to me. It's going to be really, really important that you know those perfect squares, and I'm here to support you in any way that I can. Good luck on the assignment.